limit as x goes to 0 of 2x over sine 4x times cosine 4x. The first thing we're going to do is try plugging a 0 in for each of the 2's. That'll give us a 2 times 0 divided by the sine of 4 times 0 and the cosine of 4 times 0. 2 times 0 is 0. 4 times 0 is 0. So we have 0 over the sine of 0, which is a 0, and the cosine of 0, which is a 1. And we end up with the 0 over 0 indeterminate form due to trig functions and power functions, which means we're going to make use of the identity limit as theta goes to 0 of, now since sine's in the denominator here, I'm going to write the reciprocal version of it, theta over sine of theta equals to a 1. What we have to do with this limit is isolate the sine function, which is in the denominator, so we will keep it in a denominator. All other terms go into another fraction that is multiplying the isolated sign, so we have a 2x and a cosine 4x. Keep everything in the numerator and denominator as needed. And we're now going to match the phase of the sine function, which is a 4x, in its other position, which will mean put it into the numerator. To compensate, we'll put a 4x in the denominator of the other fraction. Now in the other fraction, the x's can cancel, and the 2 and the 4 can cancel to a 1 in the numerator and a 2 in the denominator. So we can now rewrite this as limit as x goes to 0 of 4x over the sine of 4x times 1 divided by 2 times the cosine of 4x. The first fraction, 4x over the sine of 4x, is 0 over the sine of 0 with a matching phase, and therefore it has the identity, and that equals to 1. The second fraction will have the cosine of a 0, which is a 1, so that's not contributing to the 0 over 0 indeterminate form. We can just plug a 0 in, and we will have 1 over 2 times the cosine of 4 times 0, which is 1 divided by 2 times the cosine of 0. The cosine of 0 is a 1, so we have 1 over 2 times 1, or 1 over 2.